Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to episode 16 of Chemistry Connections. We're your hosts, Andrew McManimon
and Jeri Nestle.
And on today's episode, the chemistry behind acid reflux, we will be discussing acid reflux, what causes it, how it can be treated, and the chemistry behind it all.
So I guess we'll start with what acid reflux is. So, what is it, Andrew?
So, it's commonly called gastroesophageal reflux disease, or simply put, GERD. And it's the occurrence when stomach acid comes back up into the esophagus. And common symptoms include heartburn, burning chest pains, and nausea.
I have a question. Why does GERD, I'm going to keep calling it GERD, why does GERD cause heartburn specifically, do you know? I feel like they're in two different parts of the body where it's like the digestive system has the acid reflux, and your heart's part of your cardiovascular system, right? So like how is the acid coming up your esophageal tract affecting like a sensation in your heart?
So a lot of people who have acid reflux or GERD, their biggest symptom is burning chest pain, and sometimes that chest pain can kind of move over into the heart area, and it feels like, you know, that kind of part of your body is also burning too. Yeah.
Oh, that's interesting. Yeah. Well, okay. Continuing on with what acid reflux is, I guess. It's important to make the distinction between acid reflux and GERD because they are different. It's more GERD is like the chronic version of acid reflux because just acid reflux, like anyone can have it. It's temporary. Although it's interesting because we don't really know why GERD develops or how. Because, again, like the mechanics of reflux is that the lower esophageal sphincter, which is this like ring-shaped muscle separating the stomach from the esophagus, kind of fails to do its job in closing. So it lets up this excess stomach acid into the food pipe, but we don't know why it malfunctions or why it continues to malfunction in certain people.
I guess we can move into the chemistry behind it all. And I'll start by talking about the stomach acid, which is, you know, the kind of the source of it all. It's what comes back up into the esophagus and causes all these issues. It's also called gastric acid, and it's mainly composed of hydrogen chloric acid, and it's highly acidic with a pH of 1 to 2. And so for listeners who may not be familiar with the pH scale, it's based on a scale of 1 to 14.
You're so funny with that. Acid base.
Yeah.
Okay.
Yeah.
Okay.
And so the substances with a pH value of 1 to 6, they're labeled as acidic. And then those with a pH value of 8 to 14 are considered alkaline. And 7 is used as, you know, the neutral baseline in which acidic and alkaline or basic substances are being compared. And a common example of a neutral substance is pure water, so we can compare everything to that kind.
Right. Well, that's kind of funny because I feel like water is such like a healthful thing that grows plants and things, and obviously that's essential to live, but stomach acid, gastric acid is just as important for our day-to-day function. I mean, it is highly corrosive, so when it escapes from its stomach enclosure through the sphincter, it's not good for you. But while it's in the stomach, it helps break down food, to help break it down to more like nutrients and vitamins and minerals, and there's a lot of science behind it. You want to explain that, Andrew?
Yeah, sure. So generally, the digestion process works to break down the proteins we eat into amino acid chains. And so further than that, there's a super important enzyme, proteases, which work to decompose the globular structure of the amino acid chains furthermore into smaller amino acid chains or individual amino acids themselves.
Okay, that was a lot of words.
But what's super important is the low pH environment, because these enzymes can only work and function and do the digestive process in this super acidic environment. And so even though it sounds harmful, our bodies have evolved to handle this and to function.
Yeah, so basically what you're saying in, like, I don't know, English is like some enzymes function better because of the low pH nature, the acidic nature of the stomach environment.
Yeah, and more specifically, our stomachs can handle this highly acidic environment and continue to maintain it because the cells of the stomach lining secrete a mucus that protects itself from this corrosion. But the whole thing about acid reflux and why it's not good for that stomach acid to come back up into the esophagus is that your esophagus and your throat, the cells lining those parts of your body don't have the protection, and so that's why you can feel it when it comes back up.
Wait, I just had a thought. I just realized that a lot of the, like, one of the symptoms of acid, obviously there's heartburn, but also another thing that happens to people is mucus, like the irritation that the stomach acid causes in parts other than the stomach, like, creates. So I guess it's trying to create that protective lining.
It's trying to protect itself, but yeah.
Corrosion. Oh, that's interesting.
Yeah.
Cool. And to treat this corrosion or whatever, well, to prevent it from happening, I guess, there's antacids, which are like Tums and stuff, and the way they work is they neutralize the HCl in gastric acid. So, like, for example, Alka-Seltzer has mild bases in it that react with excess hydrochloric acid, and what happens is they neutralize each other in an acid-base neutralization reaction to reduce the acidity of the gastric acid, which returns the body back to normal conditions pH-wise. So, for example, calcium carbonate, which is an active ingredient in Tums, neutralizes the HCl, and so the acid-base reaction converts carbonic acid into calcium chloride and water and carbon dioxide.
I guess, like, the Alka-Seltzer and that kind of thing, they work to, like, relieve the stomach acid through, like, relieving gas, I guess, which, like, the carbon dioxide, I guess, in the water.
Oh,
yeah.
That's so true.
Wait, yeah. So I think some other common bases or mild bases to combat this issue as well also include magnesium carbonate and sodium hydrogen carbonate as well.
Well, that's interesting because obviously those are bases, and it would make sense to neutralize an acid with a base to relieve that kind of pH imbalance. But there's some, like, remedies out there for acid reflux. I know this as an acid reflux victim myself. There's, like, home remedies out there that use acidic ingredients to try to relieve that. I think you sent me a TikTok once where there was something about drinking pure lemon juice as, like, a
yeah
remedy.
So she couldn't really explain it herself, and I tried to look, but I couldn't find it. But she said that she has been trying remedies for so long for acid reflux, changing her diet and everything, and then she went to her doctor, and her doctor told her to drink pure lemon juice or something super acidic, and then it was like magic. She felt so much better, and no one really understood why, but it worked for her, I guess.
I mean, I don't know. Like, personally, my acid reflux journey has lasted like 2.5 years. I mean, I don't have GERD. I have something called LPR. I believe it's laryngopharyngeal, something with the larynx. And basically the acid, like, gets into my vocal cords and then irritates them, and then I get very, like, congested and mucousy. It's called the silent reflux or something, and, like, a lot of people have it. They just don't notice it because it doesn't interfere with their life unless they speak or sing frequently, in my case. But yeah, there were, at the beginning, like, there was so much effort on trying to focus on certain ingredients and foods and their pHs to try to, like, maintain a more basic diet overall to try to combat that issue, which honestly, I can't even say if it worked or not. I mean, I was very fortunate because my diet is already pretty basic since we eat a lot of Japanese food at home, which with, like, probiotics and stuff, it's like, it's more basic than acidic than, like, American, like, fast food. I'm sure that's very difficult for people who have that as a big component of their diet. But, like, it's very strange because there's a lot of conflicting information out there on the internet for stuff that's supposed to work. And, like, overall, from the way I can say that when I eat really spicy foods, like, obviously it doesn't make me feel well.
Yeah.
But, like,
you don't say.
For the most part, though, I feel like I don't really notice that much of a change if I, like, eat strawberries in the morning.
Yeah.
But I guess for people with more severe GERD, there would be a different case, right?
Mm-hmm.
Yeah.
Well, thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure that you visit www.hvspn.com. Thanks.